All right, hey there, ladies and gentlemen. Today we're going to be looking at domain and range. By now you should be hearing these words quite a bit. You may have heard them a little bit in 7th grade, but in algebra we refer to domain and range a lot. Domain, remember, is what we call the independent variable. Remember, it also is the input. It would help if I used a color that you can see. This is the input, the x value. This is also the word we use as domain. So domain, input, independent, x value. We also call the domain the independent variable, which you see here. And also, I want to talk about the fact that the domain runs, if we're talking about a graph, it runs left to right or horizontal. Okay? When we talk about dependent, we're talking about the y value. The y value depends on what you put in for the x. So range, dependent, this is your output value. And this runs vertically, so vertical. Make sure you're taking note of all of these things because all of those words are going to be used in reference to domain and range. So when we talk about the domain, or in this case, the independent or domain value, the domain values produce range values. Remember, when we list these values, these are always the x values for the independent variable. They're the numbers that get plugged in. So they're the production, they're the independent. They get put in to the function. When we list these, we always list them in order from least to greatest. And so when we list our domain, we can write it this way. We can say domain. We start with the colon, and then we create these fun little brackets, and we list them in order from least to greatest. So in this case, it'd be -1, 2, 3, 5, and 7, and then we close it with a bracket. I know my brackets are not glorious. So these are our domain values. Each of those domain values will produce an output value. Which is our range value. So these range values were dependent on the input. So now these are the output. So in this case, we also list them in order from least to greatest. So when we plugged in a 3, it produces a -2. When we plug in a 5, we get a +1. When we substitute a -1, we get a 0, and so on and so forth. So for our range values, we list them also in order from least to greatest. In this case, we have -2, 0, 1, and 4. Notice, even though -2 appears twice, I only list it once. So these values depend on the x values, or the input values, or the independent values. So let's look at some more examples. We can create a mapping using our domain and range. Remember, the first bubble is always your x, the second is your y. We list the x values in order from least to greatest. So we would have a -1, 2, 3, 5, and 7. We'll list the y values also in order from least to greatest, so -2, 0, 1, and 4. Then from there, we'll draw arrows to connect these guys. So -1 is paired with 0. So I'm going to draw an arrow to the 0. 2 is paired with 4. There's that. 3 is paired with a -2. 5 is paired with 1. And 7 is paired with a -2. So those are all the ordered pairs that we create using a mapping diagram. Now, one more way we can do this is using discrete set notation. So when we talk about set notation, and when we have discrete data, this is only a set of random points when we use this. So for example, each of these is an ordered pair. Just as we did before, we can set it up this way. We can say, okay, well, my domain is, and use the values in order from least to greatest, -1, 2, 3, 5, and 7, and then close that with a bracket. And then range would be the same thing, -2, 0, 1, and 4, and then of course close with a bracket. So discrete means that it is a set of random ordered pairs. So if we were to graph it, it would just be points all over a graph. No lines, nothing like that. So this would be discrete.